Hi everyone, welcome to the second video of this logistic regression series. In our last video, we talked about the math behind logistic regression. In this video, we will acquire our dataset and do some data visualization. So if you want to follow along, please install stats models from your command prompt. Stats models is basically the statistical package within Python, but it also has great built-in datasets. So we will actually be using it to just get one of these datasets. And don't worry about all these other imports right now. I will explain them as we use them. So I have a link to our dataset here. And this is actually the stats models website. So if you go to the about, you can read about them. But basically, they were part of SciPy, but they broke off and now they have their own sort of package. If you go to user guide and scroll down to datasets here, you can see that they have a lot of amazing datasets available here for practice. So we're going to be using this first one. And this is about the US election survey from 1996. As you can see, our dataset has 10 variables or features and 944 samples. So scrolling down, you can see that most of these features are categorical. We also have the vote. So we're actually going to be treating this as our response feature and trying to predict this from all the remaining features, okay? So let's actually load this data set onto our live code. So we need the stats models package to do this, so let's import that first. Okay, so then we can load our data by calling data and then, data sets, and then giving the name of the data set, right? So the name, you can get it from here. So this last part right before HTML, ANES 96. So I'll copy that. So, okay. And then you have to tell it how to load it. So I want it obviously as a pandas data frame. And then that should do it. So if I zoom in a bit, actually, if you call data, you can see it's that table with the 944 samples and all of our features, right? But a better way to look at our data would probably be to describe it and use the pandas describe function. Excuse me. So let's transpose the results and look at it. So you can see this actually reports the mean, standard deviation, minimum, maximum value from each row. So it's a nice statistical summary. We can see the vote here is a little below 0.5 in average. So that tells us that there were more zeros than ones in the column. So that also gives you a clue about who won. Actually, let's go back and remind ourselves. So 0 was clean, 1 was dull, 0. So you know what? Let's change one of these cells to markdown and keep a note of that in big bold, right? 0 is clean, 1 is dull. So now that we have a column of interest, we can use this great function called group by in pandas, which actually allows you to group other columns by the column of your interest. So I want to group everything else by the vote. And then it also lets you call an aggregate function on it. So I want to calculate the mean of all the other things, right? So here you can see it reported the means of all the other columns, but grouped it by zeros and ones. So, you can see the differences. I don't see a much difference in age between the voters. Education seems similar. So, you can look at this and analyze it. But one thing we had to do was check if there are missing values. So we can do that by using the isNull function. So what this does is basically it goes through every column and goes down the rows and checks if there are any empty rows, right? And if there is an empty row, this function returns true, so it returns 1. And if there aren't any empty rows, it just returns a 0, right? For each row. So what we do is let's actually sum all the results. So what would this do? So if you go down the columns by each row and count if there are any missing values and return a 1 if there is, your sum should be greater than 0 if there is even one missing value, right? And if your sum is 0, that means there weren't any missing values. So let's print that. And so we can see all of them are 0. So that's good news, right? That means this function didn't return 1 for any row, which means none of the rows were empty. Good. So now we can actually start doing some visualizations, right? So let's actually make 2 figures side by side, because who wants to look at one, right? I'll make some subplots, and I'll make it 2 columns, so it's side by side, and I don't want them to share their x or y. Oops. And I'll also set the fig size right now. 15 by 5 is a good one. Okay, so let's now actually, so I'm going to use Seaborn to plot this. So let's actually import Seaborn as SNS, and let's use the cat plot from Seaborn. So I want to plot the party ID, and you have to tell it where to get the data from. So that table, and what to color it by, right? So let's color it by the vote, because that's what we're interested in. And also we have to tell it what kind of graph to make. So let's make it a count of all the columns, the rows, and then also which axis to plot it on. So the first one. And then I'm just going to copy this for a second plot, but this time I'm just going to plot the education, right? And this one has to be on the second axis. So, oh, I forgot to give an equal sign there, right? Okay. So as you can see, we plotted the graphs, but if you notice, there were 2 more axes created. The reason this is happening is because Seaborn itself is a figure level function. So when you call it, it creates its own figure. But since I specified the axis, it actually still made the figure, but went ahead and plotted it in where I told it to plot it, right? So the figures it created remained empty. So you can actually get around this pretty easily by just calling a simple close on the second and the third figure. And that should, yeah, get rid of that. So, okay, let's get back to the real thing. So as we can see, there's definitely a disparity between your party ID and who you vote for, right? So let's go here. So your party ID, if you were higher, then you're a Republican, and if you were lower, you're a Democrat. So you would imagine that Republicans voted for Dole. So yeah. In education, you can see it seems like people with a little bit lower education voted more Democrat, but you can make your own conclusions from that. Let's also look at income. So as you can see, there are more bars because if you go back here, income had more categories. So seems like people of lower income little bit picked 0, and then the one peak is a little bit higher income. Anyway, so one other thing I want to show you is the logistic perspective, is what I call it. So let's actually, because as you remember, the graph I showed you earlier was like this, but how can we look at this this data from that perspective, right? So let's actually plot our party ID versus our vote, and let's make it a red, huh? Great. Oh, I wanted to do a scatter. My bad. So as you can see, this kind of looks like that graph, but it's all filled in circles. And that's because there are so many samples that they're just overlapping each other. So to actually understand the frequency, we have to decrease the alpha level. So let's decrease that. And now you can see it's sort of apparent what's going on and what our logistic regression machine will see, right? So with that picture there, I will actually finish the visualization sector. So we did all of this, and then we showed the graphs, and over here I have some more graphs, but in the next video we will actually start looking into how we can feed this data into our logistic regression model and then get a prediction out of it. So see you there.